We've seen how the normal distribution can be used to model the sampling distribution of the mean for when the population standard deviation is known. However, in many practical situations, you won't know the value of the population standard deviation. In that case, a student's t-distribution can be used. As was the case for using the normal distribution, the t-distribution can be used to model the sampling distribution mean when one of the following is true. Either the population is normally distributed or the sample size is large. A t-score for a sample mean is calculated similarly to the way a z-score is calculated. We start out by subtracting the observed sample mean, x bar, from the population mean, mu. But since we don't know the population standard deviation, we don't know the actual standard deviation of the sampling distribution and can't use that in the denominator. Instead, we estimate the standard deviation of the sampling distribution with the standard error, which is the sample standard deviation S divided by the square root of the sample size n. Students t is not a single distribution, but rather a whole family of similar distributions. A t-score will follow a t-distribution with degrees of freedom equal to one less than the sample size. We use df to represent degrees of freedom, so we'll write df equals n minus 1. A student's t-distribution is similar to the standard normal distribution in that it is a bell-shaped symmetric curve centered at 0, and the total area under the distribution is equal to 1. However, the student's t-distribution places more weight in the tails. The solid curve shows the student's t-distribution with 2 degrees of freedom, while the dashed curve shows the standard normal distribution. You can see that the shapes are very similar. However, look at the range from -5 to -2. You can see that, compared to the normal distribution, the t-distribution is higher over this tail range. The same thing is true in the right tail. This means that, compared to the normal model, the student's t-model assigns greater probabilities to larger deviations from the mean. Recall that degrees of freedom are one less than the sample size. As we increase the degrees of freedom, the student's t-model gets closer and closer to the normal model. Here's the t-distribution for 5 degrees of freedom. Here's the t-distribution for 10 degrees of freedom. Here's the t-distribution for 20 degrees of freedom. Say we wanted to find a confidence interval for a population mean when the population standard deviation is unknown. The basic idea will be the same as when the population standard deviation was known, except instead of using the standard normal distribution to find a z-score that corresponds to our desired confidence level, we'll use a student's t-distribution to find a t-score that corresponds to our desired confidence level. We would start out by choosing the t-distribution with the appropriate degrees of freedom. Recall that the degrees of freedom is one less than the sample size. df equals n minus 1. The confidence level for our confidence interval, CL, expressed as a decimal, is equal to 1 minus alpha, meaning we want an area of 1 minus alpha in the middle of the distribution between the lower t-value and the upper t-value. We'll use this to find our confidence interval. This will leave an area of alpha over 2 in each tail. So, we know we want an area of alpha over 2 in the right tail of the t-distribution with n minus 1 degrees of freedom. What t-value satisfies this? A calculator or other technology could be used to find this value, or, if those are unavailable, a student's t-table can be used. Let's go through an example. Jessica wants to find a 90% confidence interval for the mean price per pound of apples at supermarkets in her state. From a random sample of 8 supermarkets, she finds a mean price per pound of 99 cents with a standard deviation of 10 cents. What t-score should she use to find the 90% confidence interval? Assume the population is normally distributed. Since the population is normally distributed, we can find a confidence interval. Since we don't know the population standard deviation, we need to use a t-distribution. Our sample size is 8, so we know n equals 8. Recall the degrees of freedom for the appropriate t-distribution is 1 less than the sample size. df equals n minus 1. Substituting, we get 8 minus 1 equals 7 for our degrees of freedom. Next, let's find alpha. Recall that our confidence level, CL, is equal to 1 minus alpha. We want to find a 90% confidence interval, so our confidence level expressed as a decimal is 0.90. 0.90 equals 1 minus alpha. Solving for alpha, we get alpha equals 0.1. This means that alpha over 2 equals 0.05. We want to find the t-value that gives us an area of 0.05 in the right tail of the t-distribution with 7 degrees of freedom. We could find this value using a calculator or other technology, or with a student's t-table. Here's a portion of the student's t-table. Each row of the table gives t-values for the t-distribution with the degrees of freedom listed on the left. Each column specifies an area in the right tail of the distribution. For example, the column labeled t sub 0.10 gives t-values corresponding to an area of 0.10 in the right tail. We're using the student's t-distribution with 7 degrees of freedom to model the sampling distribution of the mean. So we'll look in the row corresponding to df equals 7. We're looking at the value that corresponds to an area of 0.05 in the right tail, so we'll look in the column labeled t sub 0.05. The entry in this row and this column is 1.895. So the t-score that should be used to find the 90% confidence interval in this case is 1.895.